Hello everyone, my name is Rick Malava and this is a Simply Maya Quick Tips video. In this tutorial I'm going to demonstrate how you can create this wire mesh pattern that conforms to a shape. Now I've seen this question asked a couple times in the forums, and there's a number of ways that you can do this. You can do it with a normal map and a texture, and this way you don't have to create geometry. But for cases where you actually want physical geometry, this is a pretty neat technique that I think I've come up with here. The traditional way that you would do this would be to create a set of CV curves, and then you would extrude a shape along each of those curves to create this grid pattern here. And then you would go into something like a lattice or a bend deformer, and you would go, or a wrap deformer, and you would bend the shape around whatever or this surface, or this set of extruded polygons around whatever kind of shape you want it to conform to, which can be tedious and time consuming. So I've come up with an approach, I think, that works pretty well. This is a fairly complex shape here, but most of it is pushed into the surface, so you're just seeing the top of it. But you can use it for situations like this, or cases where you want to create this sort of a grill pattern down here. This is just something I've been tinkering with. Oops. Just wanted to show you these two, not the whole thing. But anyway, I'm still working on lighting and bits of it. But anyway, this is the idea. So let's see, how can we do this in an efficient way? So what I've done here is I've created a set of CV curves that create that pattern I want, the diamond pattern. And then I created the surface that I want to conform this to, right? And the way I created these curves is very straightforward. What I did is I just came in here and created a EP curve, 2-point EP curve. Put a point down, and then holding the shift key you can constrain it to horizontal or vertical, which it didn't want to do that time. Oh, it is. I'm just in perspective mode. If I go to top. Oops. Okay, let's not be retarded here. Let's go to the top mode and go to create EP curve and put a point down, hold the shift key, and put another point down. There we go. This is going to be another 4-hour video since it's taking me hours to do simple things. So I go to center of the curve, hit Control D to duplicate it. Let's pull this slightly down like that. Now that I've created one copy, if I hit Shift D, it will copy with offset automatically. So I can create all the curves I want, select all those curves, center their pivot, and then I can rotate them to any angle that I want, right? So I created 2 sets of those curves. And then for the actual shape here, I just came in and created a polygon cube. Perspective, and then just delete this face down here. And then just take the entire object and throw a bevel on it. Right, there you go. And just so that it is more visible, you can come in here and select all these edges to make it a little more visible from all angles. Go to the top view and just extrude it out a little bit in X and Z. Okay, so it has that sort of a shape to it. Could probably get by with a little bit more. Okay, something like that. Alright. So the next thing you do is, once you have your curves and your shape that you want to conform them to, you can use the Maya Mesh Edit tool, Project Curves on Surface, which is relatively new. It was added, I believe, in Maya 2010 or above. And from the top view, well, before I do that, pick the curves and then shift-click your surface that you want to conform them to. Go to the top view and then do an Edit Mesh and Project Curve onto Mesh. Right? And then what this will do is it's now projected these curves down onto the mesh. Now, just so that I can see this a little better, I'm just going to select all the curves that were created and I'm going to group them. And I'm going to pull them up above the mesh here. Okay, so just like when you project a texture onto a surface, you can see from the top view if I take all of these guys now just temporarily and hide them, you can see from the top view that the mesh pretty much, no, that's not any better, is it? Matches the grid pattern, but from the sides they get stretched. Now if you want to be really fancy, I've actually experimented with this and it works really well. You can take and project these curves onto these faces, right? Onto these faces. Then you can take all these curves and you can rotate them 90 degrees and you can project them onto these faces, right? And then you can take the same curves, you can rotate them 90 degrees and you can project them onto these faces, right? And what you can do is actually what you want to do is project them onto these faces, and then these faces, right? And what you'll end up with is like 1, 2, 3, 4, 5 projections. A projection from the top, from this side, and then these faces and these faces, right? And then by moving the curves around with history, you can get the curves to line up really well, and you'll have this actual very precise grid pattern literally wrapped around this surface on all sides. It's a little more time consuming, but you can get really fancy with this technique if you wanted to. So I'm not going to go through that because it is it's rather time consuming, but it would be much faster than trying to shape it around something that has a complex shape by using bend deformers and lattices and wrap deformers. So now that we have all of these curves created, the general technique that would be used to create our actual mesh would be to take and create something like a NURBS circle, right? And then take the circle and the path, and then just do a surface extrude, right? Now you'd have to sit there and pick each one of these paths. You know, pick this circle, which, I mean, just now it's a pain in the butt. Pick the circle, pick the path, do the extrude. Pick the circle, pick the path, do the extrude. That's cumbersome. So I've come up with a little faster technique where we don't even need a curve here and we can just use paint effects. So once I have all these curves that were projected down onto the surface, I can select them all, right? And then I can come into the paint effects options, go to curve utilities, and go to attach brush to curves. And that comes in and it attaches a brush to each of these curves. Now we have the situation where the profile that's been extruded along each of these paths is too large. I want to control the size of this. And so with, say, this one selected right here, I can control the size of that profile that's extruded along that path by coming into the shape, the stroke shape node of the brush paint effect, and I can go to pressure mapping, pressure scale, there we go. Roll down pressure mapping, and under pressure scale, go to this selected value, and you see if I reduce this to like 0.5, right? Oop, I set it to 0.05, 0.5. You can see I've changed the diameter of that one profile that's extruded along the path. The problem is I haven't found any way to do this by selecting all of these curves and going to one setting. It only is going to affect the last thing that's selected here. So I created a little mel script, very simple mel script to do this for me. So if I come in and I select all these strokes, and then I go to my script editor here, I've got a little script that I've created which simply creates a string that holds an array of all of the elements within the selection by using this ls-sl argument here. And so this contains each one of these strokes. And then I create a float variable called SV, scale value, and I set it to whatever I want it to be, in this case 0.4. And then I create another string called node, which is temporarily going to hold each element inside of the select array. So basically for each element in the select array, write it into this node variable, and then this is for debugging. I printed the node value out, so you see it printed up here. But this is where the work gets done. I then go for each one of these nodes, which contains a stroke, right? I go to the pressure scale underscore float value, and I set it to the scale value that I have up here, and it literally just walks through each one of these elements and sets the scale. So with all of these guys selected, if I select my script here, and then I hold the control and hit enter, I get an error because I must not have everything selected. Oh, that's because I have the strokes sitting on top of the curve, so I'm selecting both the strokes and the curves. So to fix that, I'm going to come in here and just select the strokes, and I'm going to pull them up to separate them from the curves. Okay? Now I can shift select just the strokes, come over here, and once again shift select my script, and then hit control enter. And you can see in the background all of those strokes changed at one time. Okay, now these are still brush strokes, they're not geometry yet. So what I can do is there's a couple things I can still adjust before I convert this to geometry, and one of which is, and both of which I'm happy to say you can change all at one time by selecting all the objects and just selecting them in one, or adjusting them in one spot. The first thing you can change is this sample density. If I come up here and I scrub the density, you can see that it just pretty much simplifies the number of polygons in this surface that get created. Now for this case, I think I set it to something like 0.7. Right? This is going to directly affect the amount of geometry that gets created when you convert this into a polygon. Then the next thing I want to adjust is this smoothing value. If I come in here and I adjust that, you can see what it does is it spreads those curves out a little bit. Right? So I can get something a little better looking like that. And I think I set this to something like 3. Okay? Now, the good news is I can select all of these, right? And I can't, doggone it, and I can't come in here and change it here, because once again, when you do a selection, even though all these things are selected, only one is the winner, and you can't see it here, but basically the one that's green is the only one that's going to be affected when I change something here. But there is a way that I can change this in one shot by going to the window, General Editor's Attribute Spreadsheet, and that opens this up. And what you can see is for each node that is selected, it shows up in this list, along with all of the variables that I can change that are associated with each of these nodes. And fortunately, in this case, the two that we're interested in, the sample density, right, this one right here, which we've set to, I think it was 0.7, was one of them. So I can change the sample density in one shot. And then I can come down here, and the other one was the smoothing. So if I search through this, you'll find smoothing in here. Oh, it's right next to it, smoothing, and we set that to 3. Right? So there you go. And you can see it changing underneath in one shot. Now the last thing to do in this process is to once again select all of these guys. And just to simplify this, I'm going to group it so I don't have to keep doing that selection there. I can select them all in one shot. And this is interesting. If I select it as a group, it doesn't seem to highlight them. So and I haven't played with this off camera, so I'm just going to be safe, select them all again. And then I'm going to come up here and I'm going to go to Modify, Convert, and you want to come down to Convert Paint Effects to Polygons. Right? And now all of these are converted into polygons for you. Okay? Now it actually replaces the brushstrokes, so they're no longer brushstrokes. These are actual polygons now. Okay. So if I select all of those and I group them and I delete their history, right, I end up with all of these guys down here, which are now, you can see in my outliner by this little symbol here, that these are all now mesh geometry, no longer brushstrokes. And I have all these empty brushstrokes nodes here, which I can actually go through and just delete. I don't need them anymore. So there's created or converted to geometry. Now the last thing to do is to just assign a decent shader to these. So if I go to the Hypershade, now you can see for every one of those brushstrokes that was created, they get their own material. But since I've deleted all the history and got rid of those brushstrokes, if I just come over here to Edit, Delete Unused Nodes, all of those rogue nodes. Oh, I'm sorry, I haven't assigned. They're still all assigned. So let's come in here and select this guy, all of these, and then let's go to assign them a Lambert shader. Assign to selected. So now they have a Lambert shader on them, and none of these brushstroke materials are assigned to anything anymore. So if I come over here and I go Edit, Delete Unused Nodes, all of those will go away. Okay. Now I have another item in this scene that's hidden that has this material on it, so don't worry about that. But we're basically down to our base 3 shaders that we would have: the Lambert, the particle, and the shader glow. All right, so now this is now geometry. So I can take this whole group of geometry, I can center its pivot, and I can pull it down back over the top of our shape to show that it's conformed. And you can even, I like to leave the shape in, give it a different color in the background. So just pull it over the top of the shape. Like so. And we can take and isolate this so we can see a little better. And there you go, a grid pattern that's been a sort of a screen mesh pattern that's been conformed to a shape. And like I said, you can get it's stretched out along the sides here. In this particular case, I like the effect, but if you wanted to have this actual grid pattern all the way around this object, you could project onto the top faces, project onto the side faces, and project onto these end faces. And then by using history and moving the curves around, you can get everything to line up perfectly. And then you can once again add brush strokes, set the size of the strokes, the amount of detail in each of the poly surfaces that's created, and the smoothing. Convert those strokes to a mesh, to a polygon mesh, and delete all the history, clean everything up, get rid of the extra shader nodes, and you've got this pretty cool thing put together without having to worry about trying to use. If you were trying to use a deformer to manually do this, you can imagine how much time it would take to get it to fit to this shape that I've created here. And this is a really simple shape. You can create some fairly complex shapes and use this technique for it. So anyway, there you go, a way to create a mesh or a wire grill pattern and get it to conform to a polygon shape. Once again, my name is Rick Malava for SimplyMaya.com, and I hope everyone finds this tutorial helpful in your modeling. Thank you. Hello everyone, my name is Rick Malava with SimplyMaya.com. My nickname in the forums is CTBRAM, and in a previous video I discussed a method of taking an input network of curves and projecting it down onto a surface, and then using the paint effects, converting those projected curves, into a series of paint strokes, and then converting those paint strokes into a mesh so that you can effectively create a sort of a grid pattern that's been conformed to a poly shape. Now, Just like with texture projection, when you use this approach, we get stretching down the sides of the surface. So I started thinking a little bit more about it, and I came up with a slight modification to the process that gets us a little bit more of the effect that we're looking for, where this mesh is literally wrapped around the surface and not just projected down onto it. And so the way that I did that is, imagine if we start with this as our final shape, and I make a copy of it, and then from the top I do a UV projection. I pin these 4 UVs and I unfold the surface. I end up with something that looks like this as a UV projection. And then I take this surface, or this poly surface, I create a duplicate of it, I smash it down flat using the scale, and then I stretch it so that it matches this UV projection, and I end up with something like this, right? Now imagine me taking this input grid and projecting it down onto this surface. If I turn off the final shape. Now if I take this input grid, I project it from the top down onto this surface, I end up with something like that. Right? So now I've got those curves projected onto the surface. Now imagine if I take this surface and the original surface, and I create a blend shape between the two. So you go into Create Deformer Blend Shape, and I do a blend between these. So now if I take this surface and I go here, and I blend it, I can go from the flattened surface back to the original shape, right? And now I've got these curves, projected curves. I've got these curves projected onto the surface. If I use the same technique that I demonstrated in the previous video, and we convert these projected curves into strokes, paint strokes, using the Paint Effects Curve Utilities Attach Brush to Curve, then I convert all of those brush strokes into a mesh using the Modify, Convert, Paint Effect to Polygons. I end up with this. Now I have a poly mesh that's been projected down onto this surface that matches that curve network. Now if I take this poly shape and I use the Create Deformer Wrap Deformer, and I select this curve network that's been converted to a mesh, and then I select this poly shape and do a wrap deformer, that takes this poly shape and wraps it around all of these, this mesh network. And now I go back to this poly shapes blend shape node, and if I blend that back to the original shape, magically you have a grid network that is conformed precisely to that shape. Now there is some distortion. From distance you can't see it. I'm still investigating ways of fixing the distortion. You can do it, I think, pretty quickly with a lattice, and it's going to be very hard to take a surface like this. It's fairly extreme, and flatten it out and not get some distortion. But you can see from this render here that it looks very good when it's done. So that's basically the technique that I've come up with, is taking the poly shape that you want to project the curve network onto, duplicate it, do a UV snapshot from some angle, take and flatten, make a copy of that shape, flatten it out, and then have it match the unfolded UV snapshot. Then take and project or create a blend shape between the original shape and the flattened shape, right? Between the flattened shape and the original shape. Then take a curve network and project it down onto the flattened shape, convert that curve network into a mesh, or into paint strokes, and then convert those paint strokes into a mesh, and then take the flattened poly shape with the blend shape node attached to it and use it as a wrap deformer around the mesh network, and then you can take and morph it back into the original shape. So this has been Rick Malava with SimplyMaya.com, and I'm continuing to explore methods of taking a curve network and wrapping it around a poly shape and getting it to conform. So I hope you guys can find a uses for this technique. I can think of a lot of things that I can do with it. For instance, very quickly before I close here, imagine if we go back to the original shape, the flattened shape, and before I convert the curve network into paint strokes and the paint strokes into a mesh, if I went into that curve network and now I went and I rebuilt all these curves such that the control vertices sat over the top of all of the places where they intersect, and then I went through selecting every other vertex and pulled it up, and then on the and then I went through and selected all the opposite vertices and pulled them down, I would end up with a weaved pattern. Now I've got this weaved curve network pattern projected down onto the surface. If I go through the rest of the steps and convert this curve network to paint strokes, the paint strokes to a mesh, and then wrap the mesh with the poly shape underneath and blend it back, you'll end up with a not just a curve network that's projected straight down and wrapped around, but you'll have like a weaved curve network pattern. So you could actually create a three-dimensional weave network that wraps around the shape and conforms to it. So that's my technique. If anybody can continue looking into ways and come up with ways of either simplifying this or refining it or improving upon it, feel free to comment in the comment section. Until then, I hope you guys can find uses for this, and I'll continue to look for ways to model things in Maya and hopefully help you out in your projects. Thanks a lot for watching, and I look forward to hearing feedback from you in the forums.